Hello everyone, good morning. I hope my audio is clear this time. For those of you that can hear me, please just let me know if the audio is fine so that we can proceed. Um, okay, I think people can hear me good. All right, let me try to share my screen. Probably that's where the issue is coming from. Just give me a moment. Oh. Can you still hear me, please? Hello everyone, can you hear me? I just want to be sure. Can you see my slide? Can you hear me? Uh, so I'm not saying anything. Sorry, I'll soon start. I'm just trying to get to the thing. I'm trying to make sure everything goes well this time. Just give me a moment. I'll be back with you guys. So, okay, good. So I don't think I'll wait for um people to join like we did the last time because I can see the number. So if you have people you shared the link with before, you can if you have people you share the link with initially, you can reach out to them to rejoin. We're back. Sincere apologies for the glitch. Sometimes that's what we I mean. That's technology for you. But thank God we're back at least. Got it fixed. Welcome to today's session, and once again, apologies for the glitch. And we're back. I just hope you can hear me loud and clear. So, just want to ensure before we jump into the session. Good. So, welcome to session two of our ethical hacking introduction to ethical hacking course by Academy Halogen in partnership with the Cybersecurity Expert Association of Nigeria. Today is session two of a series of four series of hacking course, and we hope to make sure that this session is going to be insightful, and you'll be able to learn uh, a whole lot of it, a whole lot from today's session. Just a moment, please. Uh, so we hope today you'll be able to learn a whole lot. And for those that couldn't join us in the first session, we uh, have it online. You can request for the link, and the link will be shared to you so that you can follow accordingly. Um, so yeah, let's start. Introduction to ethical hacking. There's a session overview. So let's do a recap of what we talked about in the last class, the last module. That's module one, and we discussed about the history of the internet, where we broke down how the internet started. Started from the ARPANET and we've evolved into TCP/IP model and the likes. And then we also discussed about what is security, where we broke down security being acceptable level of risk. Um, and then we also talked about cybersecurity as a whole, where we broke down that cybersecurity is about securing data network and all interconnected devices on the web. And you also talked about the features of cybersecurity, which is the CIA triad. When we talk about CIA in cybersecurity, we're referring to confidentiality, integrity, um, and availability. So those are the pillars of cybersecurity. For you to be an ethical hacker or a cybersecurity professional, it's very important for you to understand these three concepts or three pillars of cybersecurity. So that will guide you in your cybersecurity field. We also talked about the need for cybersecurity, the importance in our society today, and why organizations and individuals need cybersecurity in their daily or day-to-day lives. We also explained what is hacking. We all broke it down, breaking into systems and the likes. And then we also broke down who is a hacker, the types of hacker, black, white, gray, script kiddies, activists. We broke all those down. All those are in the previous course. We also talked about the motives of a black hat hacker and the consequences behind that kind of an action or that kind of action taken out by a black hat hacker, the consequences that follows. We also discussed the importance of ethical hacking in today's world. It's very important, of course. So the ethical, that's why it's called ethical hacking. So the ethical hacker breaks in before the black hat hacker does. So he helps the nation. I mean, he helps the world or he helps individuals to ensure they are safe before the bad guys do. And then we also discussed the phases of ethical hacking. Where we broke it down from the footprinting or reconnaissance phase to the exploitation phase, maintaining access, and then the covering of tracks, and then also the reporting ethical part of it, and then the reporting part of it. So because you have when you go through all those processes, you have to report your findings as an ethical hacker. That's what differentiates you from the regular. That's what differentiates an ethical hacker from the regular hackers. Sorry. from the regular hackers. Where is it? Where is it? So we also talked about the legalities of ethical hacking, where you could where what could put you in trouble and what could not. Professional hacker ethics and code of conduct. Every profession has its own code of conduct, and same thing with ethical with a profession like ethical hacking. Of course, you have to maintain a particular code of conduct because you are exposed to a whole lot of things that regular individuals might not be exposed to. So you have to maintain a particular some particular ethics and code of conduct. That is what makes you ethical. So for today's module, which is module 2 and day 2, we'll be breaking down networks because for you to be a cybersecurity expert, it is very important for you to understand networking, how all these things move around the web. It's very important because you can't start driving a car if you don't know what the brakes are, what's an accelerator, what the gear, what's the work of a gear, handbrake, and all that. So same thing is that's what that same thing applies to ethical hacking. Before you jump into ethical hacking, you need to understand some basics, which is what we'll put you through today. Definitely time will permit us. So that's what we'll put you through today. Basics and fundamentals, break down TCP/IP concepts, IP address, then we'll do basic understanding of network protocols, network topologies, architecture, common network devices, where we'll talk about firewall, router, switches. Then we'll go a little bit into hacking part of it today also, which is the footprinting, which is the first. If you joined us, you know that this is the first phase of ethical hacking, footprinting and reconnaissance. So we'll take you through that first phase of it, the importance of footprinting in ethical hacking, the techniques that are used, the tools that are used, and then also we'll break down some user enumeration techniques to you today. So stay tuned to this class. It's going to be very interesting and also very, very insightful. We promise to make sure that whatever we're doing today will not be too complicated. So even if you're just coming up in the field of technology or infosec, you will still be able to catch up with the process of hacking. So we'll also be talking about the basics of network and the fundamentals of network. Today, we're talking about the fundamentals of network and basic TCP/IP concepts. Will be the first part of it. Um, so get ready. You can get your jotting pens down and start jotting because the class is about to start. Um, so we'll be talking about the basic TCP/IP concepts today, and TCP/IP concept is T for transmission, and T for transmission, C for control, P for protocol, and I for internet, P for protocol. I had to break it down like this so that people, so that's why we call it TCP/IP. You see how long it is, so we had to shorten it to TCP/IP. So whenever you hear TCP/IP, it's referring to that long sentence I just pronounced. So it's a fundamental networking protocol suite that actually facilitates communication between devices on a network. So it's like a standard protocol, like it's how it is how is the standard of how things fly around the network. It's like the rules and regulation of of networks generally. And understanding these basic concepts is very important for anyone that wants to work with computers, or maybe whether it's for troubleshooting, configuring, designing, or implementing network solutions. It's very important for you to understand this. But if not, you won't even know where to place the right solutions, or even as an ethical hacker, what to break into and the concepts in which you want to use to break into those devices or solutions. So the four layers of the TCP/IP model, we have the application layer, and we have the transport layer, we have the internet layer, and also the network layer. So each of these layer is very, very important in the TCP model. So the application layer um, generates the data and also request the connection. So that's where you see things like handshakes and all that. We'll break that down a little bit in the next few slides. So let me not bore you here yet. We also have the transport layer, and under the transport layer is the TCP and also the UDP. That's user datagram protocol and the transmission control protocol also. So what this does is that it establishes an error-free data connection, And it also splits the data into smaller packets so that the network is not congested. So when you hear us talking about packets, somebody intercepted a packet and all that, that means they just intercepted the network to pick some of the information flowing through the network. The net actually information flow zeros and ones and also in packets. So that's how it is. When you hear packets, we're not referring to your Amazon packets or eBay packets. We are referring to technology packets. And also it helps transport layer also helps to obtain acknowledgement of receipt. So you see what we call the TCP handshake here. So when okay, let me not go too deep there yet to still talk about that. You also have the internet is the next layer in the TCP IP model, and it sends the packets and ensures that the packets are sent accurately and with integrity. It also routes data through the correct network. Then the network access part adds the destination MAC address. It sends the data between the application over the network, and it also handles the physical infrastructure of the all these things you're doing actually runs on physical infrastructure. All your pictures that is on Facebook is actually somewhere in a database, maybe under one C or somewhere in in one data center somewhere. So it actually has all these things we do has a physical infrastructure attached. Then when you hear the cloud is a physical infrastructure to somewhere in one of those vendor OEMs control. So, what's the basic concept relating to networking, which I promised to break down a little bit? So, we have IP addressing, very important for you to delve. Before you delve into the field of ethical hacking, it's important you understand the basic concepts relating to. I mean, you understand a basic concept relating to IP addressing. We have IPv4 and we also have IPv6 in the IP addressing among the IP addressing options. But the most common one we have today is the IPv4, and it's a 32-bit numerical address which is used to uniquely identify devices on a network. So generally, IP address is what identifies a device on a network. So for instance, you see 192.168.1.10 on a network, and for instance, you're in a school. Every system in that school or in that office has an IP address attached to them. Every every system on that network has an IP address attached to it, and that's the way the network actually understands. It doesn't know Bankole system, it doesn't know the MD system, it doesn't know the finance person system, it doesn't know anybody's system. The only way it knows that it identifies system on the network is through this IP address that we can see on the screen. And so it's actually what translates it and identifies it on it. All even your phones has an IP address, your wristwatches, your smart wristwatches, all devices on the network has an IP address. The newer version of IP addressing is the newer version is the IPv6. And sorry, one second. The newer version is the IPv6, and it was actually created to eliminate the limitations of IPv4. So IPv4 is a 32-bit IP address, and normally since it's a 32-bit, it gets exhausted on the network. So if you have a very large network, sometimes an IPv4 IP address might not be sufficient enough to handle that large chunk of devices on the network. So what networkers do, sorry for using that language for them or name for them. What networking engineers do is that they break down the network into smaller segments so that it could be able to accommodate the IPv enough numbers of devices on the network for IPv4. So IPv6 is not really so common. It's just in a few advanced environments and then maybe in data centers that you will mostly find IPv6 implementations. We also have subnetting. It's dividing a network into smaller subnetworks to improve the network performance, security, and management. So similar to the analogy I just gave, when you break it down like that. So, for instance, you break finance has their own IP address. This last part of the you can just do it that this part of the octet of the IP address can now become two for maybe the finance department, three for maybe uh communications department, and then if you have his own extension. So once you just see 192.2 on your network, you know that, oh, this is somebody from finance trying to do this. When you see, and it's also easy for you to manage that network because you'll be able to put some limitations. That's where security now comes into play. Say, okay, all network on .2.this cannot have access to XYZ, or only them has access to this, that. So you already know, and it makes it easy for management of your network. So here it involves using subnet max, where you see things like .24, .16, to identify the networks and host portions of the IP address. We also have ports, very important in networking. Ports. And what ports are is that they are virtual communication endpoints, which is used by applications and services on a network. And what they do is that it allows multiple services to run on a single device. So on a single device, you could have HTTPS, that's Hypertext Transfer Protocol, which is port 443. You could have the normal HTTP without the S, which is port 80. You have FTP, which is port 21, SSH, port 22, DNS, port 53. But all these port numbers is not necessary for you to cram them. Is if I knew them, I knew them because I've worked with it over time. So it's not necessary you cram it. It's just for you to know it. So once you see a port, so in fact, some ports are very peculiar to an environment. So once you see, although there are some common ports which hardly changes in an environment, and so once you see a port, just check it out. What does this port do? Just do a simple Google search and you will know what it runs, you will know the services. Then, so for instance, if you check a device, you see SMTP on it, you can now check attacks for SMTP and all that. So that's where it's very important for you to understand these things as an ethical hacker. So ports actually is like a window. Let me break it down like that. There's a house there's a building, there are doors to get into a house, and then you now have windows. So ports is like the window, is like the extra, is like an alternative entrance most times for um attackers or even services. So we also have so for us to break it down a little further, we're talking about the TCP and the UDP. So UDP, very important, is a connectionless protocol that provides unreliable but very, very fast data transmission. It is mostly used for applications where speed is more critical than data integrity, such as streaming, media, and then most times people that play games. So it's very, very fast. So people that play games prefer to use the UDP connection rather than the TCP. TCP will slow down the network a little bit. It is more the TCP connection is more like it's more reliable, so it's slower, something like that, because of the security error checks and all those things attached to the TCP model. It's a little bit slower than the UDP. So for people like gamers and then some kind of communication across a particular, when I say secure network, it's maybe a backend secure network that you've put some security things in place and you want the data transmission to be really fast, you can rather use UDP instead of TCP. Then we also have FTP, which is the file transfer protocol, and it is mostly used for transferring files between a client and a server on a computer network. So for some of us that are a little bit tech savvy, we might have some of these applications on our phones called maybe file transfer, TCP, even all these what do they call this app again? Zenda uses the FTP protocol for sending files across its devices. So it establishes the receiver as the client, as the client, and you as the sender you are the server. So you are serving the client. That's how the Zenda protocol works. Actually, it's almost very similar to the FTP file transfer protocol. So the person is trying to receive maybe the picture or something from um from the other party is the person trying to receive is, I mean, the person trying to, sorry, I got a little bit, so the person trying to send the data is actually the server, and then the person receiving is the client on the network. So the basic concept relating to networking, also we have DNS, which is you have packet structure. Sorry, let me start with packet structures first. So a packet is actually a unit which I've explained before over a network. It consists of header containing control informations like the source, destination address, and then even sometimes the payload. in the and also the payload in that packet. So sometimes when you intercept a packet, you might have an idea of who is sending it, the person supposed to receive it, and the likes. And so most times, if you want to do it over a secure network, people use things like VPN and all that. So people can't do what we call man in the middle attack to intercept your packet transfer. Then we have DNS, very, very important. It's the naming system across the web. It's also very similar when I was explaining how it's actually how the web identifies at the back end is how it's what translates names into IP address. The servers at the back end does not know example.com, does not know halogen.com. It only knows the IP address attached to halogen.com. So when you put halogen.com on your browser and you press enter, it's immediately the DNS, what DNS does, that it immediately translates that halogen.com into numbers, into IP address, and it helps to facilitate communications over network. It makes it easier also for our devices at the back end to communicate across each other. So the hackers use DNS for reconnaissance also to gather information on our targets. Sometimes before we probe, I will also explain that later. Before you probe into some devices or systems on the network, you first of all do a DNS scan, and that will make you identify the names attached to some. For instance, halogen.com, we have maybe halogenacademy.com, halogen this. So you won't know that normally. But when you do a DNS scan or DNS reconnaissance on that website, it will now break down all the other subdomains attached to that website. So it's very important for us as hackers to understand the DNS concept. We also have SSH, which is the secure shell, and it's a cryptographic network protocol used for mostly remote access. So if you want to remote access into one of your servers in somewhere, one of your data center, you mostly do that over the SSH protocol. It's very, very also. It's also a very, very it's a well used protocol on the network and also across hackers. It helps you access remote. So even from here, I can actually access a server in the US or anywhere, any part of the world using SSH. And ethical hackers also try to brute force SSH. In fact, we've done that several times, brute forcing some SSH protocols to get access into some remote servers or even some remote systems. All this for test purposes. The next part of basic concepts of networking will be the network topologies. And understanding network topologies and architecture is essential for designing and implementing secure networks. So this knowledge is very, very important for hackers also. So network topologies and architecture, there's different ways in which it's actually the different ways in which a network is structured and organized, both logical or physical. And it actually defines how data flows across the network. So even you as an ethical hacker, it gives you that leverage of knowledge when you know, okay, this is a bus topology. That means the packet doesn't bounce across before it gets to my destination, or it just goes through this cable, or, so it also helps you. It's just somebody that's it's like a driver who knows. Is topology also refers almost similar to same word in our same word of top of in real world also. So it's like a driver that is very, you can't compare a driver that is familiar with Lagos to a driver that just came into Lagos for the first time. A driver that is familiar with Lagos knows that, okay, this route leads here and it goes here. So he will even be more calculative when he's driving. Same thing in networking. When you're hacking and you know the kind of topology in that organization or on that network, it helps your hacking flow. You know what to attack, you know how your packets will travel on that network and the likes. So it's very, very important concept for us to also learn. And I'll be breaking down each of these topologies for us today. So stay tuned while we do that. So the first topology we'll be breaking down today is the bus topology. The bus topology. And in the bus topology, all devices are connected to a single central cable. It's very simple, it's ineffective, but a single fault on the cable could disrupt the entire network. Just imagine you're on this network and there's let's say you're this system now, and then something happens. Let's say this wire, maybe one rat or one rodent has come to chop the wire here. Definitely, you won't have access to all the other systems on this part of the network. And so that's why it's like a limitation. Once there's a fault, it breaks the entire network communication. But in some cases, it's also very useful. You understand? So it has its own limitations, and it has its own limitations, of course, because every all the computers are just relying on a single backbone cable, which could break. Yeah. And also it could also cause collusion. It's inexpensive, so sometimes some people, but it's not scalable, so sometimes some people still go with it because of the cost effect that it has. The next one is the star topology. You can see it like a star. It's all devices connected. They connect to a central hub or switch. It offers better performance and easier troubleshooting compared to the bus topology we just explained, just like that. So imagine now something happens on this cable. It's only this system here now that will have the problem, and not the other ones. So the other ones will still be able to communicate. This will still be able to route their network to the internet. And so it also has its own downside too. It also has its own downside, which is if a hub fails, for instance, the entire network will be affected. So if this fails now, this particular hub that they are all connected to, if it fails now, then all the other devices on the network is also not going to connect. So it's not only about the cable this time. Yeah, it's easy to manage as compared to the other one, but it also has its own downsides. It's also easy to scale as compared to that one too. You can scale this one very easily. You just maybe add another, just put another device here, plug it, and you're good to go. Put another device, plug in, you're good to go. So all these network topologies have their own advantages and disadvantages. Next topology we'll be talking about is the ring topology. You can see it's designed in a circular fashion, forming a closed kind of loop. And forming a closed kind of loop. And in this kind of place, data travels in only one direction. You can see it just goes like that, only one direction, back and forth. And it's less common actually due to its limited scalability, and is also susceptible to a single point of failure, just like the bus topology that we explained initially. But it can actually tolerate a few bottlenecks. So you see, if something cuts off here, then that means you can't. Those of you here can't access here. Or maybe something cuts off here, just isolates the system alone, and then so it also has its own downside. So it's susceptible to a single point of failure. Once this fails, no more communication across. It blocks because the packet is actually supposed to travel through this to get to this. So once this breaks, that's all you get. So um although the data can actually take an alternate path, but it also has its own downside. Then we now have the mesh topology. And in the next mesh topology, every device is connected to every other device. You get the point. Every device is directly connected to each other. So it provides redundancy and also fault tolerance, very high redundancy. So because anyhow, anything goes wrong, it's still standing. If this breaks, it can still, if there's a break here, you can still read this system through here like this. If there's a break here, if I can still reach it through different ways, you can even choose to go around and still reach the system through here. So there are different paths in a mesh topology. Its web-like structure makes it highly redundant and also very, very fault tolerant. The only problem here is that it's very, very difficult to manage, and it's also very complex to implement. But trust me, it is highly, highly reliable. Highly reliable. The one of the very common one in today's world is hybrid topology. If you can see from the diagram, you can find out that we have the um, bus topology here, we have the ring topology, and we still have the star topology all in one network. That's why it's called the hybrid um, topology. So it blends it. You can mostly find it in bigger organizations or big web devices or bigger web applications. In this case, you can have one department use the bus topology, you have another department use the ring topology. You can just have different things. So in this case, it offers flexibility and also scalability because it combines the advantages of all these different topologies, the advantages. So that's why in this case, so for instance, you look at this environment, you say, oh no, star is what we use. That's the advantage there. You check here, you see, oh, ring will be the best, then you use it there. Sometimes you can even have one side client, the other side server style. So
You can make all your servers interconnected like bus topology, make all your endpoints connected like this to one single hub, and all running simultaneously without any fault. That's also another thing. It's also very fault tolerant because it's also easy to troubleshoot. You know which topology is running where and there. And in fact, you implemented it because of those advantages. So the next thing we'll talk about is the network architecture. Network architecture plays a very crucial role in enabling effective communication, resource sharing, and collaboration across distributed environments. If you can see the picture by this on the slide, you can see how the network architecture looks. It actually looks like an architecture plan, but don't get it twisted. It's not so complicated. You can see the switches, you can see core switch, you can see the endpoints, scanner. So it's well identified. So that's how a network is architectured, and it is the design actually. It encompasses the layout of components, the connection, the protocols that you've used, the components, everything, anything that facilitates data exchange between devices on the network. It helps you to define them, and it also makes those devices organized. It makes them organized also. It serves as the foundation, for building secure, reliable, and also a scalable network that mostly meets the requirements of our modern businesses or maybe organization. So ethical hackers could actually leverage this skill or understanding of network architecture to identify vulnerabilities, to also assess the security posture, and then sometimes recommend improvement to ensure network resilience, and also to also provide security against cyber threats. So, an ethical hacker now can come into this environment. Once he does his reconnaissance, he identifies that, oh, this switch is an obsolete switch. It shouldn't be placed here. The way it's connected will make an attacker from these points to be able to pass through these points. So it's very good when you understand the architecture as an ethical hacker. It will help you. You know where the vulnerability lies. Maybe it might even be the vulnerability might even be with the endpoints. It might be with the user. It could be anywhere. It could be the CCTV attached to the network on the architecture. Probably CCTV is not on an isolated network. Things like that. Somebody could hack into your CCTV, and from the CCTV get into some critical infrastructure. So having a good understanding of how an architecture should be and the standard of those architecture is also very, very important for us as ethical hackers or as cybersecurity professionals. So yes, very, very important. So the key aspects of network architecture, we're breaking it down for you. The key aspects of network architecture include the components and the devices. And as an ethical hacker, identification and arrangement of network devices such as the router, switches, firewall, server, workstations, and other things attached to the network um, is is very, very important. Also, helping you to determine the roles and functions of each of these devices within the network, also, so you know that okay, this thing is placed here. Is it placed here for switching? So sometimes you can even use the firewall for switching purpose. There are some environments where we go to deploy firewall and we put the firewall as a switcher, put it as the filtering device, you put it as a router even sometimes. And so when you look at those functions, it helps you to identify what each of those things are doing on the network as a cybersecurity professional. So it's very, very important, and that's one of the key aspects. The topology, which is like the physical or logical layout, we've explained that already. It helps you to understand the arrangements of devices. Let me even check that last slide. Let me see if you can see here that we have different topology here. We can see the bus topology implemented in some places. You can see the tree topology implemented in some places, can see star, so it's once you identify this, you know that, oh, if I'm able to attack here, once I'm able to attack here, I'm able to break XYZ. That means network to the internet is blocked. If I'm able to attack this, that means, so you see, understanding the topology and also what each of those things on the device does is very, very important. The next thing we'll talk about is the protocol and communication standards. Or everything on our network works based on some particular standards or protocol. So, for instance, we have the TCP/IP protocol, we have the UDP, we have the FTP. We've explained all that in a few slides behind. So let's not but I mean digress. So it's actually understanding this is very important for us as ethical hackers. So you know what is this, you know how to hack. So you see HTTP without an S, then you know it's not secure. You know, help understanding of that aspect of the network architecture is very, very important for an ethical hacker. Even things like the MAC address, domain names, all these fall under the protocol and communication standards is good. So all these things is like an introduction. So you need to go back and then read all these things again, even after this class. Read them, put them into practice after this class. Don't worry, before the end of this class, we'll also give you some materials or access to some resources where you can also do your own self-learning post the course. You can even reach out to me on LinkedIn and I will also share that just in case I don't handle the subsequent sessions or probably we skip that part. So just reach out to me on LinkedIn, Bankole Adekola, and I will share you some of those like call them resources or sites where you can practice your skills and then make yourself a little bit, I mean, enhance your skills in cybersecurity. So let's go on. Sorry for the digression also. We have the security mechanisms. Um, also is one of the key aspects of our network architecture. Implementation of security measures such as the firewall, VPN, you know where oh, the VPN is here, this is where they've put this, so I can circumvent it in this way. This is where they've put this, their IDPS. Maybe they didn't put it in the right place, so you'll be able to break it through this other place. So very, very important. The security mechanisms on your network is very key, and also the positioning of those mechanisms also is also very, very important. The next thing also, scalability and performance of your network is a very nice, I mean, consideration for network scalability to accommodate growth in users, devices, data traffic, without compromising the performance. So, in fact, we're having a session recently in just very recently, and we're discussing about Nigerian banks and how some of our digital banks uh, seem to perform better in terms of reliability. That's because the architecture of our traditional banks in Nigeria is very, very rigid in the sense that they have implemented most of the architecture is hardware based. And so for you to make a single change, and in fact, some of the things on some of their technology is also hard coded. So for instance, if there's a surge in customer request, they actually cannot just scale at the instant in which our digital banks do that. So the digital banks, they monitor these things, they see that, oh, there's a surge in people trying to make transactions, then they increase the number of servers. But in the aspect of the traditional banks, because those servers are physical infrastructure, it takes a whole long process for approval before they buy it, before they import those things, before the guys come to configure it. But in the digital bank era, it's very easy. They just do those things on the fly. Microservices implement, test run it works, go live. And then so you see, scalability and performance in the network architecture. I mean, it's very key. It's very key for performance and reliability of your network. But it's also very good for you as an ethical hacker to understand where all these things come into play. So you know how the network is optimized. You know the bandwidth. You know the throughput. You know all those things. Load balancing, catching. All these things fall under the scalability and performance of the network, which is very, very key. We also have one other very key part, which is management and monitoring. So the implementation of network management tools and protocols such as SNMP, which is the Simple Network Management Protocol, is used for monitoring the device status. So you can use the SNMP protocol to know the health of your device, know some performance metrics and the likes. It's also very good when you implement such protocols in your environment. And also, you as an ethical hacker, you should know how to leverage or what I call exploit this kind of protocol. So you can use it even so I can some websites now I can know the health status even without getting permission from the administrators, and that works through some of our tools or the active some websites activate SNMP, ICNP, and all those things, and from there we were able to get some status or metrics on the system. So very important for you as ethical hacker to have knowledge of all these management and monitoring tools so that you can even know how to evade them in environments where you are working. So the configuration management also ensures consistency and reliability, and also compliance. So there are some industries that you must have some kind of monitoring solutions in your environment, monitoring or management solutions implemented in your environment. Take, for instance, our banks, financial institutions. Also, you must have monitoring technology in your environment, because you must monitor how people are accessing your environment. You must monitor you must be able to monitor, manage, see how people are, see number of users, see several things. It just ensures that you are compliant. So in some environments you must implement what we call the SIEM solutions in that kind of environment. Some environments it's important to implement things like information, identity managers. Sorry, not information. It's identity managers. I wanted to say so that you don't make mistakes when you're doing your research later. So, in some environments, you have to implement solutions like the identity access manager, that's IAM, privilege access manager, that's PAM. You know, some industries it is a standard that those things must be part of your network architecture. It's standard compliance. If you don't have it, they won't even give you license to operate in some cases. So we also have redundancy and high availability. It's also it's a very key aspect of our network architecture. You must make sure that you have integrated some kind of redundancy mechanisms, e.g., failover, load balancers, fault tolerance strategies, also, to minimize the downtime and to ensure that there's continuous availability. We mentioned CIA triad initially, confidentiality, integrity, and availability. You can see where it comes under cybersecurity also. So it ensures high availability. We as ethical hackers, availability is also one of our optimum responsibilities. So we must ensure that we also understand how to implement this, where they should stay on the network architecture also, and it's a very critical network service. So some of the components on our network, or common network devices. We have the router. So I'll be very fast here because I want you to also go back later to do your research. But I'm going to mention most of the common ones you will find on a typical network, or almost all network architectures. Common network. These things are also very important when you're hacking, or even when you're in the field, or when you're trying to test your skills. Where, so if I would do what we call the trace route, where this is bouncing to, what device is here and that. So it's good for us to know what those devices do also. So don't get bored. Sorry, I know most of us want to get into the practical where we're typing, and don't worry, we'll do that maybe at the end of later, if time permits us, or in the next session. But don't worry, we have to take it, step by step. So yeah, let's not bore you, but let's go on. We have router, a networking device that forwards data packets between networks. So it determines the best path for transmission, most time using routing tables and some protocols like OSPF and BGP. So OSPF means open shortest path first, and BGP also BGPA, sorry, BGP. You can do your research on that also. But open shortest path first is what is the path when the router determines, it looks into the network and sees that, oh, this is the shortest path to get to the destination, and then it will send that packet through that path, instead of going maybe through a traditional route instead of going through a traditional route or route that might have been the option. And then the BGP is the border gateway protocol. You can go back and then do your deeper research, but don't waste too much time doing that, except if you want to really go into networking later. Because sometimes those concepts could be really, really, really confusing. So I would advise you not to confuse yourself too much. You can just skim on the surfaces of all those things to have knowledge. And later, if you feel that that's what interests you, then you can go deeper. But sometimes those concepts could be quite confusing. So don't confuse yourself and then get exhausted in the process, or fatigued um, from that. We have switches which connects multiple devices within a local network, by forwarding the data frames based on the MAC addresses, and also create efficient communication paths without collusion, which means there's no mix up of MAC addresses, mix up of IP addresses. It connects them seamlessly and forwards them accordingly across the network. We have hub, which is an old device. You might not really find it in some networks, but some networks still have it because just a hub, it connects Ethernet within a LAN, and then it sometimes it leads to potential network congestion because that hub sometimes carries only one IP address, and then by the time you plug other devices on that onto the ports of the hub, it could cause some collisions when um, packets is being transmitted across the network. They'll have modem. I'm sure most of you have heard of modem before. In those days when we used to use those kind of funny internets that look like USB drive, we used to call them modems. And the real meaning of modem is modulator and demodulator. So it's MO and then DMO, DEM. So it modulates and it also demodulates signals to enable communications over telephone lines. Converts digital into analog signals for transmission. That's actually what modem does. So that's why back then it used to be very, very common. In those days, it used to be very, very common. But even in these days, it still stands in between some of our networks. But it's not those kind of modems on network. It's not those our USB type of modems. It's some real-time advanced network modems. We now have access point. And what access point does is that it bridges wireless and wired networks, allowing wireless devices to connect to a wired network using Wi-Fi. Also sometimes used to extend wireless network coverage. So let me let me break this thing down for you. There's always this error people make. Um, People always call access points routers. I'm sure you know that people call access point routers. So those small small devices in our offices hanging on the ceiling with one blue or green light blinking intermittently is actually an access point. Technically, it's an access point, but I think the general nomenclature is router. It's not correct. A router is actually a network device, more like all those things we see in data centers. That those are the real that's the real router. So just to clear you people on that it's good to use the right nomenclature where necessary. So when you hear access points, don't start thinking of something else. It's that thing in our offices, that distributes the wireless networks, across. We now have the firewall, which as a security professional, it should be one of your, it should be like your friendliest device, if I can use that word. So, what it does is that it monitors and controls incoming and outgoing network traffic based on some security or some set rules. So it acts like a barrier, just like we call it wall behind the trusted network and the untrusted one. Any network could be trusted, anyone could be untrusted. It's you as the administrator or you configuring it that now determines what you want to call the trusted network and the untrusted one. You can block Bankole from reaching out to finance. You can block the receptionist from reaching out to the MD. All those are set rules you can do on your firewall. You can block your devices from connecting to maybe google.com, Facebook, anything, all those things. You achieve that using a firewall. So if you block it, it now see the whatever block network as an untrusted network. I will not allow access to those networks. So it's a barrier. Then we now have a gateway, which serves as an entry point, just like the name gateway. So it serves that. So when you hear gateway on your website, it's the entry point. I mean, sorry, on the network is the entry point into that network. So most times, most organizations, or yeah, traditional organizations use their firewall as the gateway also. Don't get it confused though, please. They use their firewall as a gateway, but that doesn't mean so. The IP address of the firewall, I'll explain that to you. So the IP address or the firewall will be the gateway on that network. So sometimes when I go into an environment for pen test and I do a scan and I see the gateway, I automatically know that that gateway address is the firewall sometimes. Sometimes you might also be wrong, and I'll tell you why. So because it serves as the entry point into two different networks, the firewall also stands as a barrier. So where will you put it? Where will you put the firewall? Of course, on the gateway, on that gateway. So most times that the traditional setup in environments, um, but not always. So don't get it twisted. You can do your research further, gateway and firewall. But sometimes that's a typical configuration in environment. So it's the entry point. So it's the gateway. You see your IP address 192.168.7. Your gateway could be 192.168.1 or .0. It's the entry point most times into the network. So we have the network interface card, which is a hardware component, although we have it virtually too. When we are configuring in some environments, we do it virtually too. We have a virtual network interface. We also have what we call software defined networks. Let me not confuse you, but you can do your research later. It's called SDN. So in that kind of configuration, the network interface definitely will not be a hardware component. In that case, it will be a virtual component, and it allows connections, medium, Ethernet cable into wireless signals. So the next part or aspect of our course for today, which is now going a little bit technical. So sit back, relax. I hope you've had some snacks. We're about to get into some technicalities again. So we have the footprinting and reconnaissance. Um, and it's very important. It's a very important aspect of ethical hacking. If you were in the first class, you would have seen that this is in phase one of ethical hacking, footprinting and reconnaissance. And what that does is that there are two critical phases actually, and it helps us. It's very similar to a real life scenario. So you can see the photo there. It's like when an army wants to attack a region or a country, what they do first is that they go there, observe, see what, okay, these guys don't lock their gates, even thieves. So yes, let me use that. Before thieves steal, they'll come. They say, these guys, they don't lock their gate until 10 p.m. Oh, this is how they drive in. Oh, they're always two. They don't have a security man. All those things are the groundwork for you to understand. It's the groundwork for those thieves to know how to attack that house. It's the same thing for us in ethical hacking. The reconnaissance and footprinting part is the first stage, is very, very important, because so for instance, just like the thieves robber scenario too, it's very important. They won't just bomb into your house. They now know that, oh, okay, this guy, they lock in gate till 10. So more wait till 10 before we attack. Okay, this guy in policeman we get gone. They always sleep by so time. They resume until 8 a.m. This is the best time to attack. So same thing goes in our networks also. Once you identify all those things, oh, this port is opened, this service is running, this is the operating system version they have, things like that. It's the groundwork you are doing before you now do the real thing. So footprinting actually involves passive. So actually, it involves passive information gathering to understand the target's infrastructure and also the attack surface. And then reconnaissance involves actively probing the target to validate findings and identify specific vulnerabilities for exploitation. But there are two key distinctions. There are, sorry, not two. There are key distinctions between those two pairs, which will break down more for you. They are very similar, but there are some distinctions between them. I'm sure if you heard my last lesson, one was passive and one is active. So reconnaissance actually, or sorry, footprinting is the systematic uh, process of gathering information about a system, about a target system or network, to identify potential vulnerabilities and also to gather intelligence. So it's passive information gathering technique, and it focuses on mostly collecting publicly available information about the target. And most times this is done without any direct interaction with that target. So it's more like a reconnaissance mission, but in this case, you are observing the target from far, and then you are now piecing, you're now piecing the clues together based on what you have found. And then the initial based on what you have found. So you are collecting data passively, you're not intruding into the person's privacy. The person doesn't know. You're maybe checking his Facebook, checking his LinkedIn, checking things like that. You can even check companies LinkedIn, see the kind of things they use on there. So you from their LinkedIn adverts, you can know. Sometimes you can even have an idea of the kind of infrastructure in some environments. So for instance, you go to the LinkedIn page of one website.com, and then they are requesting for a system admin with the ability to handle Windows Server 2025 and Linux one thing with checkpoint firewall and Sophos firewall. You already have an idea. They've already told you that they have Windows Server this, they have uh, um, checkpoints, things like that. They now tell you basic must have understanding of this. So you already know that, oh, they have these devices in their environment. That's already footprinting. They don't even know. It's the advert they've pushed out that has been giving you that knowledge. So you have not even interacted with any of their systems yet, but you already have an idea that there's Sophos there. They even told you, sometimes they even, like I told you, server 2025, they even specify the server version there, do things, things like that. You're already footprinting that kind of an organization. You have an idea of what's obtainable um, with them or what's obtainable there. So reconnaissance is often referred to as recon. Most time we call it recon. We're doing a recon. We're doing a recon, and is active probing of the system or network, mostly to gather more information, and then also to validate the findings which we got from our footprinting phase. Like the example I gave with the LinkedIn, I've already seen now that, oh, they have Windows Server 2025, they have Sophos, they have checkpoints. The next thing for me now to do is, okay, let me now verify. So I now ping them, check this service, check this version number, do this, do that. Because so what I'm doing is I'm building on what I did passively. Now I'm doing it actively because now I'll ping that system. I'll maybe one mmap command and say get operating system version to report it. Get this to report it. All these things I'm doing, all these packets I'm sending is connecting to that server directly. So it's active. If somebody is on that network monitoring in real time, they will see those your packets and they can now investigate and even block you. So that's why sometimes you do your passive first before you do your active. So you now verify those things. Oh, true, there's server this. Maybe in the process you even discover that there's another thing, running in the environment that they didn't even put in the advert. So, it's active in this case because you're actually touching directly on the system. It involves direct contact, the security posture. There are several kind of scanning techniques for us to observe this, which we'll break it down. Don't worry. So the next paragraph is actually breaking down the techniques used in footprinting. I don't know whether I should give us a break a little bit so that we're not too bored. Maybe it's getting too much. So some of the techniques for footprinting. Should I give us 5 minutes? Let me see the comment section. Should I give us 5 minutes? Um, So there's audio, but we'll be back. We're on a break. I'm seeing some people saying there's no audio, so we're on a small break, and we'll be back.
Welcome back. The 5 minutes break is over. Sorry, it can't go more than 5 minutes. Um, So let's start. So those of you that might have left your system, we're back. We're back to continue. So the next thing on our slide is footprinting techniques, and we're breaking down some of the footprinting techniques we use as ethical hackers or as cybersecurity professionals. It's in your favor for you to do some further research post this course to help broaden your knowledge. So the first, the most common footprinting technique in the cybersecurity field is the open source intelligence, which most times you may have heard some cybersecurity professionals say things like OSINT, I've heard OSINT, this, that. So OSINT actually means open source intelligence. And how this applies to us is that we use publicly available information, such as the search engines like Google, Bing, and social media platforms, LinkedIn, Facebook, company websites, forum, job postings to gather information about the target organization. Anything could be of value to you when you're doing your open source intelligence. That's why sometimes we always advise, even as cybersecurity professionals, for some company websites that they should limit some of the kind of information they put on the company website, even on the social media platforms. It could pose some kind of risk to that organization. Even when you are posting things like the job, especially technical inclined roles like this, you should be very, very careful on the kind of things you post online, just in case you have access or you're in a position to advise people that do that. You could use open source intelligence to collect details about employees, the technology used, even the organizational structure, the partners. So I can from LinkedIn know that okay, there's an MD, there's a CEO, there's this, there's that. Maybe there's no COO, there's a COO, there's several things. I can use it to understand the organogram of the organization. The next thing that we also use as ethical hackers is the who is lookup. And the who is lookup is we use it to query the who is database. And who is, just as the name implies, is who, who is this but in this case, it's for domains. We use it to check who is, I will experiment all this maybe in the next class. Very, very easy. There are even some websites that you can use for your whois lookup. You just go to those websites. You type in the domain that you're trying to check, and then from there you get some. You can just do a Google search now and say who is database, and then from there play around some websites, see what you can get about it. Sometimes you can even see the phone number of the people that made the website. You can see their address, you can see the person's name, you can see the person's email. From the who is, just do a Google search, say who is, and then from there play around it. Gather details about the domain register, registration date, domain expiration, all those details you can get from the who is. So I used to tell people, so let me just yeah, so I used to tell people too that sometimes, I'm sure we all know these our Ponzi schemes that are raining in Nigeria now. Or yeah, Nigeria mostly, where they will tell you that bring 15,000 and pack 14,000 every month or every 2 weeks. From you first of all deposit one particular amount, then you'll be withdrawing maybe one particular amount every week. So what I always tell people, because of course we all know that those things are scam. So sometimes you can do your own due diligence. That you can do your own open source intelligence on those kind of platforms. What you do is you just do your who is search. You can even see when they registered the website. So sometimes they rely that it's been existing for the past 6 years. But when you go to the who is database, you'll be able to see when that web application was registered, the people that registered it, and all those basic information. So of course, an organization that told you that they've been running that business for the past 4 years, is only you that did not hear about it. When you check their who is um information, you are seeing the domain was just purchased in February, or even sometimes was just purchased in May, something like that. So I always tell people too that if you want to invest, to check first, see if na new platform, cash out and move.
but don't overspend. So sometimes you do your due diligence like that before jumping into things like that. You can also check validity of websites before just do your due diligence and do your due search. We have what we also call DNS interrogation, and how this works is that you conduct a DNS query, to discover the domain names or subdomains or DNS records associated with a particular website. So, for instance, halogen.com, now I do a DNS query for halogen.com. Then I'm seeing that halogen.com has halogen.com forward slash um, maybe academy, halogen.com forward slash cyber. And initially, I didn't know. Sometimes even some of those subdomains could be hidden. Sometimes the administrators don't even want you to have access. But when you do that query, you're not able to know you're able to know the domain names associated with it, and then even the subdomains, their DNS records. From there, you can even know if they have some email issues, you know maybe they didn't properly implement their DMARC records, they didn't properly implement some MX records. All those things are all some of the things you can get from your DNS interrogations. You also know the IP address. So when you know those subdomains, you even know the IP addresses attached to those subdomains. You now have social engineering, very common. Social engineering is one of the most common um, attacks in Nigeria. Now, most of our Yahoo boys in Nigeria are social engineers. Actually, that's their name. They're not hackers. They're actually social engineers or scammers. So scammers are actually social engineers because they engineer you to divulge some kind of information. So, they leverage some things like interaction with the employees or the stakeholders. They could even send some emails requesting for a proposal or requesting that they want to come and pitch one solution to you, and then you divulge your information to them. From there, they know some of the things existing. They've engineered you. Sometimes they walk into your environment like legit people, ask some questions, sometimes they even do cold calls. They do cold calls. They call you. Those guys that call us and say, you just want one thing on DSTV to activate it. We have sent you one code. Kindly share us that code. All those things are social engineering. And of course, one of the major ways for us to, one of the things for us to evade social engineering is for us to always be aware. Don't jump into divulging information to people. I always tell people too. For instance, if I'm sharing if somebody calls me, maybe a friend or a colleague calls me and says, "Hey, bro, share me can you share me login details into XYZ?" I always tell people, don't. Fine, let's assume what you do is call that person back, do your due diligence, know if it's the person, crack some jokes about some things that is only familiar with both of you to be sure, because that's a very sensitive information you're trying to share. And then even if you can't do that, for instance, he sent you that thing via email, send him the username via that email, and then send him the password, maybe through WhatsApp or through another medium. But don't share login details, complete login details on one single medium. So, because even if, for instance, it might not even be hacked at that point, it might be genuine. But what if the person gets hacked in future and someone has access to that mail or that SMS and then logs into all those devices that you've shared those login details to? So that's why it's always good to separate the information when you're trying to share login details. You share username separate, you share password separate. One through SMS, maybe one through even phone call, the other one through SMS, one through, something like that. So that's just a quick tip. That was digressing, but it's a quick tip for us to all learn. And also make sure you always activate multi-factor on all your accounts, all your devices, any form of access. Always make sure that you don't always, if wherever the option is available to use more than just the password or a PIN code, please utilize it. Where you can use, even if you can, even our phones, I'm sure some of us lock our phone with password, PIN code, biometric, facial recognition, almost anything, pattern. Some people have almost all these kind of locks on their phone, and then on their social media or their banks, they don't even have anything, only their password. And so that's how or attackers are able to jump into our account. So always make sure that you have multi-factor. Stress, even if the attacker ends up getting access, at least you have stressed the attacker. You didn't just allow him enter a password and he was good to go. At least you gave him an extra work to do, you know. And even sometimes if it's too difficult, they get bored and then move on to simpler targets. And so that's how it works actually. So it always make it difficult. Any way you can make it difficult. Your passwords, use some kind of funny names, use your traditional name, mix it with some English word. No, play around it. That's a quick tip. Sorry for the digression. Back to our track. Now, network scanning is the next reconnaissance technique, which is very, very important also. We use it, we do port scanning, we conduct port scans to identify using things like Nmap, any mass scan, any tool that you're comfortable with. We use it to identify open ports, services running on that system, potential entry points into the target or the network. And most of these things, most this time, network scanning is done with some particular tools. You see, this because this time we're interacting directly. This is an active reconnaissance, and so we do it using tools like Nmap, Metasploit, and the like. So Nmap is called network mapper. Just do your research. Masscan also, it scans large networks in bulk. So and when you do that kind of scan, you identify. We'll do all these practicals in the next session. So stay tuned. Um, we also have what we call service enumeration, and under port scanning, we you use to enumerate the services running. So sometimes when we're in an environment, we do the first scan, we know that okay, this is there. The next scan, we add some parameters to our nmap command, and then it brings back the results even of the service version. It even tell you you're running TCP/IP version on this point. This you're running Open SSL version that, and all these. Even sometimes the configuration and potential vulnerabilities. If it's a website, you can use things like Nessus scan. You can use it to identify several configurations on the website and where some vulnerabilities are lying. So we have network scanning tools like that. Then we now have vulnerability scanners. It's also one of the very, very important reconnaissance technique. And the vulnerability scanner uses automated vulnerability scanning tools like Nessus. So this is entirely different from the first one I pronounced. Okay, sorry. The first one I was talking about is not Nessus, is Nikto. Nikto. Um, so let me just because of this let me just type it for you. So it's called Nikto. I just mixed it up in my head. So Nikto is the vulnerability scanner for websites. You use it for scanning websites. I hope it's so I hope it's big enough though. I hope you can see that. So it's used for scanning websites. So it's Nikto. Pay attention, Nikto. You can do your background research later when we're done with the class. So that's it. We have Nexus, and then we have OpenVAS, we have Qualys. So those are some of the well-known vulnerability scanning tools in the arsenal of the ethical hacker. In yeah, in the arsenal of the ethical hacker. Um, we use it to identify some known vulnerabilities. So if you see the version number, then you know that oh, there's a vulnerability associated with this version number, things like that. You also use it to access the risk posture, and then you use it to from there you can now prioritize the vulnerabilities for further investigation or maybe exploitation. So you see a particular vulnerability. Sometimes the client will want you after running your vulnerability scans to exploit that vulnerability. Let them see the extent at which you can go with the identified vulnerability. So the vulnerability scanners help us to also do that. It's very quick, very fast. So sometimes it helps us to speed up our process of ethical hacking. You just deploy it, it will scan, and you come back with vulnerability. Sometimes it can even tell you how to exploit some of those vulnerabilities. Professional tools like Nessus, Qualys, OpenVAS. Sometimes they will even tell you how those vulnerabilities can be exploited. So take note of them, do your further research later. OpenVAS is one of the, I think that's the only free one among this, on this list. OpenVAS is open source, just as the name implies, so it's free, um, but very difficult to configure. You can reach out to me, I'll help you if you need to. So OpenVAS is free. Nexus, you have the free version, then you have the paid version, which is the Pro. Same thing with Qualys, is also paid, but they are also very, very, very powerful tools for us as ethical hackers. Um, then we also have another set of tools, which is the web testing, and we have web crawlers. And what we use web crawlers for is to scrape the web, identify, maps out actually web applications or websites. It will identify endpoints, and then also sometimes discover some hidden resources, almost similar to discovering hidden domains. Same thing when we're doing some of our web crawling, because you crawl the entire website. Almost every link on that website will be crawled, will be touched. That's why we use such an automated tool, because you can't do that manually. When will you finish? Some websites have over 3,000 URLs. How do you want to get them? In fact, over 30,000 URLs or 30,000 points. How do you want to touch all that manually? So we use it. We do that using automated tools. The automated tools we now display it for us in an ordinary manner, and then we can now go through all those things manually to identify some of the vulnerabilities there. The next one is web application scanners, and then some of the tools we use for web calling is Bob Suit, OAuth Zap. So there's a tool called Z Attacks Proxy, that's Zap, or sometimes Scrappy also helps us to do some web crawling. There are several web crawling tools out there. Just do your search for the search. Then we have also web application scanners. Scanning is also one of the techniques we use when conducting reconnaissance, and it helps us also to do automated scans where we detect things like SQL injection, cross-site scripting, directory transversal attacks, um, CSR, CSRF attacks, which is the cross-site request forgery attack. And sometimes also some of the tools we use for this web application scanning is the Bob Suit, the Zap, Bob Suits, Zap, and a whole lot of, even the Nick 2 I just mentioned also. When you use it to scan, you will find all those things. You will see some vulnerability. It will tell you XYZ is vulnerable to cross-site scripting, things like that. The next part of it is the DNS interrogation. We do DNS interrogation also for reconnaissance. I think we've talked about this in the past also, so there's no need to go over this again. So the next thing we should talk about should be the tools, right? The tools we use to achieve the techniques of reconnaissance. In this world of ethical hacking, your tools are very, very. In fact, any business at all, say if your tool, the tools you use is very, very important. There was a guy that came to fix up some ACs in an apartment, one of my apartments, and I noticed how fast he was, and one of the reasons why he was very fast was because of the kind of tools he had. He had tools for almost everything. He was cut. He wasn't hitting the wall to cut it, to break through. He was using drilling, automated hammer, cutting machines. Almost everything he did that day was all using tools, and in less than how many minutes he had fixed quite a large number of ACs, and he was done. So tools and your utilization of the tool is also very, very important. So tools is very useful for us too as ethical hackers. So some of the tools for footprinting and reconnaissance I'll just mention a few of them. Footprinting tools, for passive information gathering, we have Google advanced searches. So in Google search, we'll try to touch down on this also later, in our lab sessions. Google advanced searches, where you add some operators into your Google search to discover some specific information about the target, sometimes websites, file types, related content. So sometimes I'm sure some of you that do research very well, I'm sure sometimes you have gone to the web and you've gone to Google and you're like, introduction to ethical hacking dot pdf or introduction to ethical hacking dot powerpoint. You get all those kind of things. That is you trying to do an advanced search, because on a normal day, if you just want to do a normal search, you just say introduction to ethical hacking. But in this case, you have now put an extra operator. Sometimes you can even add in URL. Don't worry, we'll show you all these operators later. Just you can also do your research and then find some of those operators. I don't want us to go too I don't want us to digress too far and then get bored. So we also have another tool which we use for information gathering, for passive information gathering, which is the Harvester. And what the Harvester does is that it gathers email addresses, subdomains, virtual host, and then even open ports from public sources. It's like a mixture of the Google Advanced Search, but in this case, it's also we also use it to gather email addresses, subdomains, and then it doesn't just search only Google. It also goes as far as using some other it also attaches itself to some other, we like call them APIs now, or servers, and then it searches for you on Bing, searches for you on LinkedIn. So, for instance, if I don't have email addresses of people in Halogen, I can just go to the Halogen website and then use the harvester to harvest all the email addresses in that domain. And if you collect it from all the sources, everything, I'll just say I need all email addresses that end with halogen.com, and it will start pulling it out from all sources, different sources. It will search LinkedIn for anybody that has uploaded anything with that email. It will search some files. It will search. That's how it works. It's the harvester. So it will search different search engines to make sure it provides you the information that you have requested it for to provide. So it depends on your parameters, how you impute them, they'll provide you the kind of results you need. We also have what we call the who is lookup tool, which we've talked about before. Maybe we shouldn't bore ourselves going back into there, but you can also do it. You can do your who is scan. It's also one of our tools we use for passive information gathering. You can even get administrator contacts, you can get domain registration date, time, and all those details. If I even get the date, the time of when that person registered that domain. Yeah. So one of the yeah, you can get it. So just do a Google search, play around domain search, and then just do who is lookup tools on Google search, and then play around it, check some domains. One other search engine, or will I call it footprinting and reconnaissance tool, is Shodan, which is what we have there. Shodan search engine is one of the Shodan search engine is one of the very important information gathering tools we have in our arsenal as ethical hacker. And what it does is that it's used for discovering interconnected devices and services, providing information about exposed ports, protocols, and technology. So in this case, can search an entire geographical area, and then it will tell you that. That's why when I tell people that, people don't even know who they are attacking. Sometimes they don't believe it. So they just Showdown will just provide you an information of, can just say, okay, search this area, tell me all the networks there that are vulnerable, tell me all the companies that have vulnerable XYZ, and to do it and provide you with the results. Tell you exposed ports, tell you technologies that they are running in their environment that has that already technology in the environment that has some known threats or vulnerabilities, all those things to provide it for you in this showdown dashboard. We also have what we call Multego, which is like the visual link analysis tool. It gathers information and correlates information about people, organization, and infrastructure from various online structures. Various online sources. So what Multego does is that you gather all those information about, if you put it that it knows information about some particular people, to gather the information together for you, place it together, do all those things. And yeah, it's a very fast tool also for reconnaissance. We use it a lot. Then we also have what we call built with, which is one of the tools we use to know some of the technology that a particular web interface is built with. So you get the nomenclature there. So it's used this for you use it to identify technologies, the frameworks, the CMS running, some analytic tools, the host providers. It will give you all those information. Same thing is an online tool. Just do a Google search and check for it. Just say built with. Go on your Google, go on browser, open Google, then search built with. Play around the tool also, see how it works. Then we also have footprinting tools for active information gathering. So we've talked about passive. Now it's time to talk about the active. Nmap is one of the major tools. I don't think there's any hacker that doesn't use Nmap. It's a very cool tool and very sweet and powerful network mapper. So one of the very, very important tools is the Nmap. Is very versatile. You can use it to do OS. You can use it to identify operating systems. You can use it to do service enumeration, host discovery, even for vulnerability scanning. So it's a very, very powerful tool. Hackers don't joke with it, or cybersecurity professionals don't joke with it. There's the Windows version. You can play around with it. It's called ZenMap. It's called Z, Zen, and then map. Don't mind my handwriting. I'm using mouse. So ZenMap, very important. So you can install ZenMap on your Windows machine and just play around it. Then we have Recon NG. It's also a very powerful reconnaissance tool in the arsenals of ethical hackers. Um, it's a fully featured reconnaissance framework, and it integrates multiple reconnaissance tools like Google, Bing, Whois, and it's used for automated data collection. So sometimes instead of um spending time on all these Whois and co, you just go to your recon and input some commands, and you get almost all the results you have got using all those individual tools. But sometimes it's also good to verify those tools, those things individually, maybe before using the recon ng. Another one is Metasploit, very popular. A lot of people know about Metasploit. It's an exploitation framework that actually includes auxiliary modules for information gathering. It's actually an exploitation tool, but there are some additional modules. That's what we call them, auxiliary modules. And those auxiliary modules, we have different ones, but we also have one for information gathering, and we can use it to do things like network discovery, service identification, reliability. So very similar to Nmap in this case. I think there's something like that. Like mm, it's like a blend between Nmap and itself. So it uses some of Nmap services to actually run its scan. We also have what we call Bob suits, or we can also say Bob suit, or Bob suit. We also have Bob suit, and Bob suit is a very comprehensive web application security toolkit, and it's used for web crawling, scanning, and intercepting HTTP requests too. With Bob suit and even this other one called Z-Attack proxy, you can intercept the traffic, play with what's the content of that traffic, and then send it. It's a very sweet tool. Oh. Let me not even go there. Both of them. So very, very, very powerful tool. Very, very powerful. If you know how to use Bob suit or Zap, you can hack almost any website. It's very, very powerful. You can intercept the traffic along the way and then modify it and then resend it to the server, modify it to send it to the client. Different things. Very, very sweet and powerful to Bob Suit Zap. Take note of those two tools, play around them, learn them in depth. Zap and Bob Suit are almost the same thing. Bob Suit is a paid version. Zap is fully open source. So Bob Suit free is also there, which you call community version. But the community version comes with some limitations. You can't do automated scan, you can't do some things. So when you pay, you now have access to the full feature. But for this app, it's open source. Just that sometimes people say it's a little bit complicated and Bob suits, which is expected because it's free. So yeah, um, that's it. You also have DNS Dumpster, which is a very, very powerful tool also for DNS records, subdomain, and the likes. Some additional tools which couldn't make it to the list, but are also very powerful. We have Social Engineering Toolkit, SET, SET, Social Engineering Toolkit, and it's used for collection of a lot of information online. I mean, sorry, a lot of information about the target collection, things like mostly social engineering, mostly things related to social engineering attacks. Use it for credential harvesting, use it for information gathering through manipulation. You manipulate the user. Then we also have what we call Spiderfoot, which is also an open source OSENT automated tool. um it also gathers um it also gathers information from various sources too. We have email harvesting tools like hunter.io also, which is used for extracting email addresses and also associated information from public sources. So you see most of these things are all public, 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 but some of them also are very active, like the ones I mentioned. Some of them are active, but some of them too, they gather information from the public. Also, we have several web scraping tools like Scrappy, Beautiful Soup, and all those other things, which extract things like the structure, directory structure, or files or metadata of websites. We also then now with next thing is user enumeration techniques. Very, very important aspect of ethical hacking. We're almost done. I think this is like the last session, so you can still please just stay tuned. We'll almost be done, and then pay attention also because we are getting a little technical, and then you can take notes as much as possible. Um, so user enumeration is very important, and it's the process of identifying valid usernames and user accounts on a particular system or network. If you can see if you can see the example we have on our screen, you see that we typed in admin and we can get the response that says username does not exist, and it has already given us an information. So it's a very I know this information is very very valuable because it can help us to launch attacks. So for instance, now I put admin, it says does not exist. Then I'll now try administrator. You understand? Maybe to now say, oh, wrong password. You get, in this case, we now say wrong password. Then now I knew that, oh, okay, there's a user called administrator. Then now that means now I won't stress myself again trying to look for username. All I'll try to do is trying to guess the password now. So it's very important too. We use it for brute forcing. So once you know the username, like now if as we put admin, it told us wrong password, then I know that, oh, there's an admin, and then I start firing different types of brute forcing attack, all the other well-known attack, even password guessing. I'll now focus on what I want to guess very well. So it's just mostly used to um validate um to get to identify valid users, and it can be achieved through various techniques, and we'll be breaking down some of the common techniques for you today. So one of the most common one is the login error message. And the login error message is many log forms provide feedback messages upon failed attempt, which is like what we just explained now. So upon the failed attempt, we got this info. You get, if you fail again, we maybe will password now tell you password does not exist. We now know username exists. So it based on the error message the application throws back at us, it now makes us to know the next step to take. And most times attackers try logging names, different things, and then a random password. If the response is invalid name, then stuff like that. You keep trying till you now at least it helps you focus on what to try. Then we have forgot password functionality. So sometimes some of the forgot password functionality allows users to retrieve passwords by entering their username and email address. And if the application reviews username associated with entered email, attackers can now leverage this to now get a list of valid usernames. Sometimes these things are automated. Oh. There's a tool that will just be testing on these things. Anyone that goes through it, will come out as green. Anyone that doesn't, it will come out as black. There's a list of username. We call them word list, username word list. You can download it from the web, GitHub or anywhere. It's called username list. Sometimes it comes in thousands of usernames. To keep trying, and then to be observing the response that the website is giving. From there to know if some of those things. So that's how I build the list of our username. Then we also have registration forms with username availability check. And how this works is that you have had a situation where you're trying to sign up on the website and then you enter Bankole Adekola and it says that name already exists. You see, it has already told us. See, that name already exists. Kindly try another name or something. So by that, I now have an idea that, oh, okay, this name exists. This name doesn't. You get. So I can now try Bankole Adekola 111 or something and then see if it will work. If it says you can use it, then that means nobody like that has registered on that domain. So probably I'm trying to think, what could Bankole have used? Maybe I'm trying to hack a Bankole account. What could Bankole try Bankole A, I try Bankole this. When on the registration page itself. So you don't even in this case you're not getting when you keep trying the wrong username in a login form, it could stop you. But when you go through registration forms, it's endless. You can continue trying to register, keep trying. So so that's why sometimes attackers or ethical hackers we move from login error into registration form checks because there's no limitation for how many times you can check availability of a name. So I just give you that tip. There is no limitation. So a confirmed username indicates its validity in the system, and from there, you know, attackers can proceed. So in this case, we can keep trying to create a username, keep trying. When it now tells us that, oh, not available, I'm sure you get the point. So now we have response time and size discrepancy. So in some cases, some applications might have slight variation in response time or size depending on whether a username exists. So an attacker can now send automated queries with different username and then measure this subtle difference in the potential time it takes to tell me it's a valid username. So how will I explain this? So for instance, they're trying to break into Bankole now, and the website has some kind of, you know, all those things it takes to respond. I'm trying a password, and then I've tried Bankole as the password now, and I see that the app quickly told in less than let me it's not that, maybe let's say in the app responded in 6 microseconds that it was a bad name, it was a wrong password, right? 6 microseconds. Then I now try, and my password is, let me see, my password is actually, my password is let me say, actually Bankole. So the person has tried, he got a response in 6 microseconds. Then he now tries another one, let's say Adekola now, and he now gets a response in uh 4 microseconds. So that gives you an idea that, okay, I think this website starts with B, so it took some time to say, okay, first character correct, second character wrong. So that microsecond time it used to check shows that the B was correct. Then you now try another one again, maybe you now try BA. It takes almost the same 6 seconds. Then you now try BB. It doesn't, error based, I mean, time. We now use response time. Some of the tools that give us this insight is Bob Suits and Zap. So from there you can now know how the app responds. Oh, okay, I tried this, it responds. Then from there you can now start building what the password could be based on the time response from the application. But like I said, these days there are several improvements to application design, but it's still a very good possibility to and sometimes very stressful too, because that's some long timing. That's why these days it doesn't really work. But sometimes you might be lucky, you find one old website or some developer that you know didn't pay attention to detail, and you'll be able to exploit that. Next one is social engineering, which we've talked about, which is a common enumeration technique, and it involves tricking people into revealing the information. So just like the way we know our people that will call you, I'm calling you from Tilso Bank, and you register this, but we need this detail. So all those things are social engineering. It's one of the ways we use to enumerate um, users in cyber security and ethical hacking. So of course, those are the techniques, and then now the tools. So some of the tools we use for enumeration is Hydra, and Hydra is a password brute forcing tool, and it supports username enumeration. So it keeps trying based on some list of passwords or username. You just automate it; it will be trying by itself. Then we also have Bob Suit, and it's with some features for analyzing login mechanisms, and then the response behavior, just like we said, to identify some valid usernames in that manner. So at the back end of Bob Suit, you'll be seeing the response, and then you'll be able to know if you'll be seeing response time, you'll be seeing some parameters like that, at the back end, and you'll be able to determine some few, you'll be able to get some insights into what's going on the application. Then we have Nmap scripting language, Nmap scripting engine, which we call NSE, and it contains some scripts like LDAP search, SMB enumeration for users, and then all these are used to enumerate accounts on the AD sometimes, through it does LDAP, AD, or SMB services. One very popular tool is the Metasploit exploitation framework, and it has modules like the auxiliary scanner, which you mentioned before, and then those are some of the small examples of the codes you can try with the auxiliary scanner. And then it's mostly used for enumerating of users through the LDAP or the SMB services. Okay, so that's the end of the class. So funny enough, actually, we're supposed to end by 2 o'clock today, which we'll try to keep up to time. Um, we'll continue next week or in the next session. I might not be the one taking it, but definitely it's a continuation of today, and you'll be having and getting an overview of you'll be getting an overview of web application architecture, vulnerability assessment, the difference between vulnerability assessment and penetration testing, um, exploitation frameworks and tools. We introduce you to some exploitations, how those things are exploited, and then the techniques for also exploiting some of those vulnerabilities. We'll also break it down next class. We'll try to be very fast because it's going to be a mixture of theory and practical henceforth. Next two classes will be a mixture of both theory and practical. But in the time being, if you're doing any research and you need assistance, you can just reach out to me and I'll support you. So for today, we talk about what we have learned today. I hope you guys learned a lot today. Apologies for the initial glitch earlier on. What we learned today was network basics and fundamentals. Basically, we touched on the basic concepts of TCP, IP address ports. Then we did understanding of network protocols, network topologies and architecture, common network devices and the likes. Common network devices, firewall, routers, switches, hubs. We talked about a whole lot of network devices today, and also in the course. We did footprinting and reconnaissance, importance of footprinting, some of the footprinting techniques that we have, techniques for gathering information about targets, some of the tools for footprinting and information gathering, user enumeration techniques, and that was the end. User enumeration techniques, and then we also talked about some of the tools for user enumeration also. I hope today's class was informative enough for us. And thank you very much for joining. Thank you for actively participating today. And see you in the next class. So if you're able to follow this course, I mean, across board, try to go through the first one, second, and third, even up to the last class. There's a possibility of you to be able to build up your career in cybersecurity. On the last day, too, we'll also give you a breakdown of some certifications and some resources you can also take. You can also reach out to me on LinkedIn and also, break that down for you too. But this is like a building block for a starter in cybersecurity and ethical hacking. It's a building block. It's introductory, and for people that are very, if you're able to pick up on it, you'll be able to from here kickstart a full-fledged career in cybersecurity. So you don't even need to study sciences to be able to be a cybersecurity professional. It's about your research, your skills, and your readiness to learn about new trends and technology. So it's an open field. We even need a whole lot of we need a whole lot of skills. I mean, to come and join us, new hands to join us also in the field. Even though AI is taking over, we still need a whole lot of human um, involvement in cybersecurity field. So you are very, very much welcome to join the field. And this class is supposed to prep you up or to motivate you to on that career path. You can reach out to me, Bankole Adekola on LinkedIn. Um I think someone shared my LinkedIn profile earlier, so you can just click on the link and from there um reach out to me on LinkedIn, and I'm always available to answer. In fact, I typically respond to my LinkedIn most times in less than 24 hours, sometimes instantly. And yes, just follow me on LinkedIn, keep the questions coming. And yes, thank you very much. Have a lovely weekend. Enjoy the rest of next week also. Take your time, go through the course again, and enjoy the rest of your day. One more time, apologies for the initial network glitch at the beginning of the class. Thank you all for still staying with us and for the resilient spirit from the participants. See you guys in the next class. Thank you very much and God bless. Cheers.